Dear students, I welcome you for the today's lecture related to the codes and standards in the subject of chemical equipment design. The codes and standards, the need for the standards that is arise due to the evolution of this modern engineering industry. So with the modernization and developing the engineering concepts, this need of standards and codes has been developed in the years, and its a basic purpose is to have the interchangeability between the different manufacturers. Means suppose I am one of the manufacturer and B is the second manufacturer, and D is your customer. Now the customer should have that flexibility so that he should be able to purchase it from A as well as from the B. So looking into the interest of the customers, these manufacturers, they have developed and accepted certain standards and codes which will be uh, abide to them, and they are going to follow that for developing or fabricating the different equipments. It was first introduced by the Whitworth, which is the screw thread standards related to the screw thread. And the responsibility of this preparing the standards, it is by the industry persons generally. So committees of persons from the appropriate industry, it is the demand of an industry that they should be able to get the standard material which I can purchase from any of the source. Then secondly, the professional engineering institutions like our institution of engineers, then AICHE, IICHE, all these professional institutions, they help in developing these standards. That is also one of the functions of these institutions and the other interested organizations. So this is the main responsibility of our industry, the professional engineering institutions and the interested organizations. They're going to decide the standards and which will be accepted by all manufacturers and the customers. Then in engineering design, they cover generally the material properties and composition. So what should be the material for a particular material? What should be its properties, like say strength, stress, strain, then the composition when you talk related to how much percentage of iron, how much percentage of nickel, chromium, molybdenum, whatever the specific material that is there, its composition they have defined it. Then the certain testings that is to be performed. So these testing procedures for performance, composition and quality, they have been also defined by these industry persons as well as the professional engineering institutions. Then what must be the preferred size? When you purchase a pipe in the market, you will get a 1/4 inch pipe, half-inch pipe, 3/4 inch pipe, 1 inch pipe, then 1.5 inch, 1 and 1/4 inch, 1.5 inch, then 2 inches, 2.5 inch, and like that. So these pipes and of the preferred size, then what must be the length? Length is also defined, whether you will get the standard 10 feet pipe or with 15 feet or 20 feet pipes. So that is overall be standardized. And then the methods for designing, inspection and fabrication, how they are designed, how they are fabricated, and its testing, that is nothing but the inspection. So codes of practice for plant operations and safety. This is the last but the important factor that is related to the safety aspects. How the plant that is to be operated, standard operating procedures, are they being followed in the industry or not? So if certain material, say your sodium, if it is hazardous, then it is having the certain standard operating procedures. By that procedures only one has to handle that sodium. So that is related to the plant operation, that is nothing but your standard operating procedures and the safety factors. Not only that, the equipment manufacturers, because we are dealing in this subject more focused related to the equipment manufacturers, we are not mostly related to material properties and composition in this subject. Then testing procedures are also not also not we are going into the detail. Then preferred sizes we are not going into the detail, but we are talking about the methods for design and the fabrication. So these two topics, the design and fabrication, that is of our concern, following the course of practice for plant operation and safety. So this fabrication, that is nothing but your equipment manufacturers, they also work to the standard to produce the standard design and size ranges for commercially used items. When you talk commercially used items, that is your standard pipes, walls, fittings, small vessels, when you talk related to household vessels, as well as the pressure cookers, then nowadays these overhead water tanks. So all these are the commercially or commonly used items. But when you specifically talk related to the industry, you can get the standard size of the equipment, say 1 meter diameter, 1.5 meter diameter, or 2 meter diameter. But above that, one has to specifically fabricate that depending on the requirement, because the cost involved in these vessels and fabrication, they're huge. So nobody is ready with all these equipments. So once you get the order, then and only the fabrication that can be done. Then for designers, the use of standardized component sizes allows for the easy integration of the piece of equipment. So integration, that is one of the most important aspect. For a say a vessel which is available, and for that vessel I am connecting a nozzle. So the nozzle pipe diameter, it should be with the standard dimensions only. Then and then I will be able to attach the standard other standard pipe to that nozzle. So similarly, if you think for a pump, now in an industry you require this so many number of pumps in the industry, centrifugal pump, which is most commonly used. And if I am going to develop or use the standard centrifugal pump, so it will have the standard foundation plates, standard inlet and outlet diameter pipes, then standard motors that will be used. So once if all these standard dimensions are available, then and only then I will be able to facilitate my production unit or the installation of the equipments, so that I will be ready. I can put the order for centrifugal pump. Based on that, I'm knowing the dimensions for foundation plate, pipe connections. I can give the another order for that correspondingly. Similarly, the electric motors, I will have to put the another requirement with the manufacturers, so that all the facilities or the all the accessories required, that will be facilitated when we are using the standard equipments. Not only that, when we are using the standard equipment, they are more cheaper as compared to the specific equipments. Means whatever the designing I will have, I have to design that, but at the time of using it, I will switch over to my nearest standard dimensions, nearest standard dimensions, which will be readily available in the market. That is what available in the market, that will become more cheap as compared to my specific requirement. But that should not necessarily be the optimized one. Optimized one is what I have designed with the standards. But these optimized, they will be costly in comparison with the standards. So I am going to use the standards only instead of using the optimized or designed one, because of the cost considerations. And if there is say 5 HP pump, 5 meter cube per second flow rate you will be requiring, and another 4.5 meter cube per second flow rate that is required, two different pumps. So I am going to use the standard flow standard pump, which will be providing me the 5 meter cube per second pump. So that such as these motors, pumps, again the heat exchangers, pipes and pipe fittings, all these are there in the standards. Then for operating company, this standardization of the equipment design and sizes increases interchangeability. That is the thing. Interchangeability. When I talk, I am having the 4.5 meter cube per second requirement pump and the another 5 meter cube per second required pump. Instead of putting the two pumps in spare, I am going to put only one pump in spare, which will be of a 5 meter cube per second, which will be serving both the purposes, the purpose of 4.5 meter cube per second as well as the 5 meter cube per second. So that is what the standardization reduces the stock of the spares that must be held in your maintenance store, and ultimately that is going to reduce your overheads, that is going to reduce your costs. Then the nearest standard size will normally be selected on completing the design calculation. That is what we are doing the roundup. That is called the roundup. But this will not necessarily be the optimum size, though, as the standard sizes will be cheaper than the special sizes. It will usually be the best choice from the point of view of initial capital cost. So I am going to reduce the cost when I am going to use the standard size materials. Then the primary purpose of the design course is to establish the rules of safety related to the pressure integrity of the vessel. It is basically for the rules of safety. The accidents should not happen, or the minimum accident should be there, and that is why all these rules are to be followed. So provide the guidance on the design, materials of construction, fabrication, inspection and testing. So these are all your guidance, but one has to understand these guiding rules and regulations and develop and fabricate the required equipment. But there are certain limitations for these standards. Now generally how these standards they are developed, that is by the committees of the persons from the appropriate industries, from the professional engineering institutions and the interested organizations. They will understand the different problems which are there in the industry and accordingly design to the standards. So that is related to the nature and the history they are knowing it, and based on this nature and the historical aspects they are going to design the standards. So there is a limitation that they do not necessarily incorporate the latest techniques. That is one of the major limitations for these standards and codes, that is the incorporation of the latest techniques, because it is based, whatever the standards and codes, they are based on all historical and past experiences only. So there are different techniques to modify the processes, and uh, these are there are limitations to accept all these new modifications and new techniques in the industry. Is this is the one reason that past history, past record, whatever the past record that is there, that is very essential or important to work it in a proper manner. Then there are different international organizations for standardization. This coordinates the publication of the international standards. So all these different organizations and professional institutes, they approach to this international organization for standardization for publication of these international standards. Now there are different standards, that is Indian standards, American standard, British standard, German standards, then Chinese standards nowadays. So talking to the Indian standards, that is the Bureau of Indian Standards, that is the BIS. Then Engineers India Limited, EIL standards. Now, in addition to that, when you talk related to the American standards, that is the American National Standard Institute, ANSI, then ASTM, that is the American Society for Testing Materials, then ASME, American Society for Mechanical Engineers, then API, American Petroleum Institute, that is going to provide the boilers and pressure vessel codes, ASME and API, that is going to provide the boiler and pressure vessel codes. Then NFPA, that is the National Fire Protection Association, this is related to the safety. Then TIMA, that is the Tubular Exchangers Manufacturers Association, which is associated with the heat exchangers. Then nowadays ISA, that is the Instrumentation System and Automation Society. This is related to the process control. That is everywhere their role is different. And if you will talk, this is the American Society. So it's a society they have developed. Social responsibility they are doing it. It's a manufacturers association they have developed all these standards. Then in case of your British standard institutions, in case of your Chinese standard, that is the GB, GOBO, all these are the standards. So in all the major industrialized countries, the design and fabrication of thin walled pressure vessel is covered by certain national standards and codes of practices. So that is related to the national standards. Every country is having its national standards and codes for practices. And in addition to that, it is necessary for certain legal actions or legal requirements that the pressure vessel must be designed, constructed, and tested in accordance with the parts or all the parts of the design code. So that is the legal requirement also. In case of accidents, the responsibility should be there. And for that, this legal requirement that is coming into the picture. The most widely used standards is the ASME boiler and pressure vessel codes. That is the ASME BPV code. This is the most commonly used. And even in many countries, these ASME codes, they are used as it is. Most chemical plant and refinery phases fall within the scope of this section 8 of the ASME BPV code. This section 8 contains the three subdivisions. That is the division 1. This is contains the general rules and is most commonly followed, and particularly for low pressure vessels. So these rules, they are provided, that is for the low pressure vessels. Not, I am not going to use a high pressure in this. That is related to the division 1. So division 2, that contains the alternative rules. So little bit rules, they have been changed, that are more restrictive on the materials, the design temperature, the design details, fabrication methods, and inspection, but that allows the higher design stresses, and hence the thinner vessel walls that will be more useful. So this design 2, division 2, that is referred for the thin wall vessels, because it is incorporating more restrictions on material, design temperature, design details, fabrication method, and inspection. So all this is related to the thin wall vessels, which will be helpful in using the high pressure vessels. And division 3, that is again for the alternative rules, but again for the greater design pressure, that is more than 10,000 psi. You can imagine the 10,000 psig. It's a huge pressure. So it does not establish the maximum pressure for vessels designed in accordance with the division 1 or division 2, but provides the alternative rules that can be followed for thicker walled vessels. So depending on the thickness, for low pressure or general pressure up to 1 to 15 kgs per centimeter square, one can go with his division 1. Then as we are going to increase the pressure, that goes into the division 2, and for extremely high pressure, that has to be followed by the division 3. Similarly, these European unions, they also manufacture and use of the pressure system is covered by the pressure equipment directives, and that is the pressure equipment directives. These are the general national codes and standards, dictate the minimum requirements and give the general guidance for design and construction. But there is a limitation that to a certain extent these are all defined, but if we want to go into the details, that is extension beyond the minimum code requirement, so there will be a mutual agreement between the manufacturer and a customer that will be there, and that will be abide to both the manufacturer and customer. So it is very important that the design should be carried out using only one code. One should not be mixing the different codes or different standards. Only one standard that is to be followed. I'm going to use the ASME standard and then I'm going to use the British standards. That is not accepted. if I am going to follow the British standard, then only I have to follow the British standards. That will be there. Mixing of these standards while designing and fabrication is not allowed. Then some commercial softwares are there which will help to design at a faster rate. So in these commercial softwares like your ChemCat, ASPEN, all these commercial softwares, they are already provided with these design standards and codes. If you will go into the details by which method you are going to design a heat exchanger, that is also provided in that detailed fabrication process. So these programs will normally be used by the specialists who carry out the detailed vessel design. So one has to go into the details, then and only then the person will be able to understand all these codes. First is a general procedure that is to be followed. Then when you go into the details of the designing, then you will be requiring all these codes. So one has to follow all these codes. Our designing procedures are mostly related with the fabrication, with the basic concept or basic formulas and the designing procedures, standard designing procedures. Besides that, there are also some free trial versions like your DWSIM softwares. This is a app also. You can download this app DWSIM and you can work to get the basic idea related to the designing of the various equipments. Then there is a design factor. This design factor, that is nothing but the safety factor, which will be used for the tolerance in design. That is, design is an engineering as well as it is an art also. To reduce the errors and uncertainties arise in this design, the basic design data available is should be perfect. Whatever the experimentations they have been taken or carried out, that data that should be perfect. Then and only then you can you will be easy and the error-free design that can be produced or fabricated. So also in that the approximation necessary in the design calculation. What are the different approximations? Which points are to be focused and which points are to be neglected? Which factors are to be neglected? That decision is also very much essential and important, and that is why it is not only the engineering but it is also an art perspective also to certain extent, but majorly it's the engineering aspects. Then the designers include a degree of over design known as the design factor. So whatever the design I am going to have the next higher values, next higher standards. That is what the over designing. It is for the purpose of the factor of safety. These design margins are nothing but the factor of safety. In mechanical designing of the pressure vessels, the design factors are used to allow the uncertainties in the material properties, design methods, fabrication, and operating load. So, where can be the different errors? That is related to the material itself. मटेरियल के प्रॉपर्टीज टेस्टिंग जो कुछ किया है उसमें कुछ एरर्स हो सकते हैं. Then your design method, there can be certain errors. Then at the time of fabrication there can be certain errors, and again at the time of operation there can be certain errors. But considering all these errors, these design factors become more and more important. So this factor of around 4 on the tensile strength, when you specifically talk about the tensile strength, that is the uncertainties in the material properties. The tensile strength will be associated with the material properties. And that is what the factor of around 4 on the material strength, or about 2.5% on the 0.1% of the proof stress is used in the designing. So this design factor are also applied in the process design to give some tolerance in this design. Each of the specialist design group will add its own factor of safety, that is depending on the design group, the engineer group. They are going to decide this factor of safety based on the different considerations. How long the duration, then what are the risk factors, what is the money constraints. So all these are the different major considerations while taking into account this factor of safety. The companies often specify the design factors in their design manual. While selecting the design factor, a balance has to be made between the desire to make sure the design is adequate and the need to design to tight margins to remain competitive. Cost factor, सेफ्टी भी चाहिए और अप्रोप्रिएट कॉस्टिंग भी चाहिए. ये दोनों का कंसिडरेशन करके ही डिजाइन और फैक्टर ऑफ सेफ्टी हैज टू बी इनकॉर्पोरेटेड. If it is a greater uncertainties in the design method and the data requires the use of bigger design factor. So ये जो दो चीजें हैं, that is uncertainties in the design data and the approximations in the design calculation, these two factors and the level of safety, these factors are more concerned for providing this design factor or the safety factor. Now there are different safety approaches also associated with this. The disasters caused by pressure vessel accidents could be totally prevented if the designing, fabrication and construction pressure vessel codes, they are to be followed, operating procedures, then your testing and inspections, then the record keeping and monitoring and interpretation of that, then alterations or repair of the vessels, then safety training for the employees and for the operators. So all these are the different factors which are related to the safety that one should be safe when he or she is operating into the plant. So the designing, fabrication and constructing the pressure vessels to comply with the applied codes and standards. All your designing, procedure of designing should be followed stepwise with the standards. Then the fabrication standards, they are also to be followed. Testing procedures, they are also to be followed. Standard testing procedures, they are also to be followed. Then when operating the vessel at a pressure below the maximum allowable working pressure with a proper pressure settings to the relief devices, that means we are providing the safety relief valve or rupture disc, so that if the excess pressure will be there and that will be released to the atmosphere in a suitable manner, in a safe manner. So that is the handle these design pressures and temperatures, fluctuations in pressure and temperature that can be properly handled by providing the safety relief wall or the rupture disc, that is nothing but your safety devices. Then the periodical testing and inspection of all these equipments, all these vessels should be carried out on a regular basis. Whether the corrosion or erosion that is getting uh, developed, then general thinning of the vessel walls, that is also to be detected. Nowadays, the ultrasound techniques are used for detecting this wall thicknesses. The next is the record keeping of inspection reports and monitoring. So when it's the weird monthly basis or 6 month quarterly basis or 6 monthly basis, all these inspections they are done, and whatever the data that is available, that should be properly interpreted so that certain conclusions can be taken whether this will be suitable for the purpose of the operation or not. Then ensuring that the alterations or repairs of the vessels, almost all industries they carry out the certain repairs on their regular basis or certain alterations in their fabrication because of the process requirement and process modifications which is will be always there in the industries, are only done by the competent and authorized persons, and repair must meet the accepted industry quality. जो कुछ repairs है, they should also be following these standards. कि कोई भी ऑपरेटर या कोई भी फैब्रिकेटर काम कर रहा है, that should not be there. They should be authenticated authorized persons which will be following all the codes and standards even for your repairs and alterations in the process plant. Then one has to provide the safety training for the employees on the jobs related to the hazard and anticipated conditions that could be causing the chaos in the plant. Then periodically provide the training for operators on the vessels, operating procedures, avoid the overpressurizing, as well as providing them with the adequate and suitable instructions for vessel safety operations. So all these are to be considered for the necessity of pressure vessel standards and codes.